Hi, my name is Bruno and I'm a technical educator at the Web3 Foundation. Today I'm going to tell you about how Bitcoin and Ethereum can cooperate and collaborate through Polkadot network. Let's get started. So, on one hand, we have Bitcoin, right? We have this original blockchain which in 2009 changed everything and unleashed the freedom to send transactions anywhere at any time to anyone in the world. No matter who's watching, no matter who doesn't want you to send the money, right? So we have this incredible new thing that is pushing freedom of finance all across the world. However, in the past 10 years or so, Bitcoin has indeed attracted a lot of institutional investors, and banks and a lot of big cats have invested a lot of money into it, and that's why it's still leading in the market caps of the world, because it simply contains the most value. It's got this first mover advantage. However, Bitcoin has stagnated technologically, unfortunately, for various reasons, but in general, you're not really able to extend it technically as much as you might want to. So you can't really program this money, even though it is digital money. And programmability allows you to do with your money what you would to put your money to work, essentially. In Bitcoin right now is just gas that's able to transport itself. Like, imagine if you had fuel that's only able to transport itself to another location. Quite pointless, but people might want to speculate on the value of that fuel. However, there are other methods of putting your money to work in other different blockchains. So now Bitcoin in terms of progress has stagnated a little bit, and maybe is even under some sort of threat, I would say, existential threat, with all of these other blockchains, perhaps, could be, because it's just not adding these functionalities that other blockchains have, namely programmability. Now, I'm not saying that Bitcoin is going to die without these functions, because after all, that was never in the original idea. The original idea for Bitcoin was never to be this extensible multi-computer network of custom applications. It's quite literally just digital cash, right? But it's having trouble being digital cash as well because of high transaction fees and long confirmation time. So that's kind of a bummer. And then you have Bitcoin kind of under threat here. On the other end of the spectrum, you have novel platform, Ethereum, which appeared 5 years after Bitcoin, and it promised to be the world computer. It promised to help everybody run decentralized applications on several thousand computers at the same time all over the world. And what Ethereum set out to accomplish is the Web3 vision. So it wanted to make it possible to send a message to anyone, anywhere, at any time, and that message could be a transaction or just hello, or even content that other people didn't want you to see. Think of the Chinese firewall, for example. So Ethereum has this booming ecosystem now where it's the money on the Ethereum platform, Ether, is fully programmable, and the tokens that you can create there are also fully programmable. These are all the various cryptocurrencies you may have heard of. They are mostly deployed on Ethereum. And there are many products today on Ethereum that facilitate this phenomenon that's called DeFi, or decentralized finance, also known as open finance. This lets you put your money to work in a way that is familiar from the traditional finance world. You can lend out your money to others and get interest for it. You can speculate, bet, and convert assets between one another. You can even invest in synthetic assets. So you have on-chain corresponding synthetic values of real-world assets like gold or silver. And you can trade with those 24/7. You don't have to wait for the stock market or the asset market to open. So this is very decentralized and free. The problem with Ethereum, and especially while it's still in this little so to speak, bubble, is that it has very little liquidity, very little market cap. So this entire DeFi thing is actually a bubble. It's not a bubble that in the financial sense that it's going to burst, though that might happen depending on some bugs in smart contracts. But it's a bubble in that it's isolated from everything else. Everything happens within that little bubble, and external value has a very hard time getting in there. Now, it would be quite nice if you could take the value that currently exists in Bitcoin, right, and get that over into Ethereum. Now, several projects exist that try to do that, that try to move Bitcoin onto Ethereum, and some of them rely on you over collateralizing, which means that you put in more Bitcoin than the Bitcoin tokens you get on Ethereum. That's a system where you lock up your Bitcoin, and a similar amount of Bitcoin-like tokens on Ethereum are just created out of thin air. Then when you destroy those on Ethereum, your Bitcoins are unlocked. Then there's another system which calls for full custody, which means that you send your Bitcoin to somebody and trust them to mint the tokens on Ethereum for you. And then the reverse happens when you want to exit Ethereum onto Bitcoin back again. This implies a lot of trust, which is kind of goes against the blockchain ethos. You don't want trust, you know. You don't want to have to trust somebody not to run away with your money. That misses the point. So you have these solutions, all of them imperfect, on moving Bitcoin's value over to Ethereum. Now, what if there was a system that allowed us to do this in a decentralized and censorship-resistant way that is also immune to these exit scams that might happen, or bugs? So we have a system called Polkadot, and Polkadot is a network of blockchains. Now, it's more than that, but in this context, I'll explain it as a network of blockchains. So Polkadot is a system through which other blockchains can communicate. At its core, Polkadot has what's called a relay chain. So we have a relay chain, which is, sorry, this is really ugly. We have a relay chain, which is kind of the main chain in this Polkadot network. We want to be able to transfer Bitcoin in a decentralized way over to Ethereum, and Polkadot lets us do that. Now, Polkadot has this relay chain in the middle, which is central to the entire operation. This relay chain has what's called parachain slots, right? So these slots on this chain allow other chains to hook into this system. Think of it like wall sockets, like power sockets. You plug into it, these are ports, and you plug into those with external blockchains. So these can be completely custom blockchains unrelated to Polkadot. They can just plug into these holes. Now, every chain that connects to Polkadot, now this is going to look something like this. There's going to be a chain, let's call this a chain, and that's going to connect to this slot. Every chain that connects to Polkadot is called a parachain. So this is a parachain. Parallel chains, because there can be many of them in parallel, and these parallel chains are connecting to Polkadot. Now, parachains can be completely separate chains that have nothing to do with Polkadot whatsoever, but they can also be bridges to other existing chains. So if we have an existing chain and we didn't really want to build one from scratch, but we just want to bridge to it, we can do that. Now, every parachain, so a bridge is actually also a parachain. And now, every parachain has these so-called collators. And collators are software machines, or software programs being run on people's hardware that are monitoring the situation and relaying information between the main relay chain, so that's this, and the external chain, so that's in this case Bitcoin. Now we can connect this bridge to Bitcoin, and now Bitcoin is bridged to Polkadot. I'll explain that a little later. So we have these collators who are monitoring both Bitcoin and the relay chain and translating information between them, basically. And now you have this this bridge to Bitcoin here. So let's imagine that we also have a bridge to Ethereum in the same vein, some collators, and that bridge is bridging to Ethereum. So now we have two bridges to two chains, and they're both connected to the relay chain in the middle. But what can the relay chain really do with them? So there's this thing called the cross-chain messaging protocol, which allows blockchains to talk to each other. So if this slot needs to talk to this one, it can just send a message to it. If this one needs to talk to this one, it will send a message to this, or to this one, or maybe to this one, and so on and so forth. So in this case, we want Bitcoin's bridge to communicate with Ethereum's bridge, because we want Bitcoin to transfer onto Ethereum and back again. under some certain conditions. So what actually happens here is as follows. Bitcoin, imagine there's a user, so we have a user, and the user has a stash of Bitcoin, right? So they have some Bitcoin. Now the user wants to put that Bitcoin to work on Ethereum. They want to be able to use the DeFi ecosystem available in Ethereum, which is booming and has a very large user amount and a decent amount of liquidity at this point. I think we're at $500 million of value locked in DeFi on Ethereum. So this is obviously something you don't want to pass up in terms of Bitcoin, in terms of your value being locked on Bitcoin. So what this user does is he uses a custom user interface that is developed to interact with these bridges. And through these bridges, he'll be able to interact with both of these chains, because that's going to be abstracted away from him. It's going to be, he's not going to be aware that he's even doing this on both chains. To him, it'll all look like one system, and that's the end goal, to make it as simple as possible for every user that is participating in the system. So what he does, technically behind the scenes, is Bitcoins are going to be sent into the bridge. So the bridge is going to have an account on the Bitcoin blockchain, and the Bitcoins are going to be sent to this bridge and locked up. So Bitcoin has the ability to lock tokens for a determined amount of time, and so these tokens will be locked. Now, since the bridge is custom made to serve this functionality, it has some other checks that it can do, and some other functionality that it can pass on. So the user will provide an Ethereum address. They will provide the Bitcoin Ethereum address. They will provide the Bitcoin, and they will send this to this bridge. This bridge will make a note of the sender of the Bitcoin and of the Ethereum address. It will then send a message through the XCMP protocol to the other bridge on the other end. This bridge will recognize this message, and since it's configured to understand the messages automatically through Polkadot network, to understand the messages coming from the other bridge, what it will do is there will be a smart contract on Ethereum which mints, let's say, Polkadot BTCs. So Polkadot Bitcoin tokens are 1-to-1 in value with actual Bitcoin, but they live as tokens on the Ethereum blockchain. Now, when this bridge gets this information, the owner, this bridge has an account on Ethereum as well. So it has an account as a user on Ethereum, and that account is the owner of this PBTC smart contract. Now, when this bridge gets a message from the XCMP, from the Bitcoin bridge, that a new deposit has been made, this bridge will initiate a command to the account on Ethereum, which will then pass this command to the PBTC contract to mint exactly as much. If he sent X Bitcoin, this will mint X PBTC to the Ethereum address that was passed in. So this guy will get the ETH address from the message before, and this message will be this address will be the recipient of these minted PBTCs. And now the user who probably owns this Ethereum address, so that's the same person, he now has this much PBTC on Ethereum to do as he pleases with it. Now he can do whatever he wants with this Bitcoin on Ethereum. He can put it into DeFi, he can earn interest on it, he can trade with it, he can speculate, he can lose it. But when he decides to exit the Ethereum ecosystem and wants back into Bitcoin because he feels it's more secure, because it, for example, has more hash power, then he will send these tokens, these PBTCs. So PBTC goes back to this bridge. So goes back to this account, to the account of the bridge. This account will use the smart contract to burn these tokens. So these tokens will burn. They're burned, they're destroyed, they don't exist anymore. The message about the burning is sent to the bridge. the bridge recognizes, all right, so XPBTC have been burned, and the burner was the Ethereum address in question. Now the user, while he was initiating the burn command from his common UI, he also specified a BTC address. So now we burn XPBTC, which means you unlock XBTC at the address that the user has provided. So the user doesn't have to be the owner of you don't have to send it back to the same Bitcoin address from which you originally sent it in, because you can just specify the address to which you want to unlock Bitcoins on the other end during your burn command on Ethereum, which means that somebody who's not the original owner can also pull out the Bitcoin if he owns the PBTC, which enables trading with Bitcoin on Ethereum. Right now, if you want to send Bitcoin to somebody, you have to wait for an hour for 6 confirmations to go by, and only then is it considered safe. On Ethereum, you are good to go in 15 seconds. So that speeds up Bitcoin itself. So now we've explained how you can transfer Bitcoin back and forth between these two ecosystems and why you would do that. What we haven't explained is how is your Bitcoin in this bridge when it's locked in there? How is it safe? You know, what makes this actually unbreakable? Why can't the bridge run away with it? And the answer is collators. So these guys, these collators, they're kind of like the miners of this bridge. They keep it safe. They keep an eye on this bridge, and they keep an eye on every change on Bitcoin and every change on the relay chain, including the messages about burning from Ethereum and everything else. So they keep an eye on this, and only once they all agree that a change is valid will they all submit a block in this bridge which allows for something to happen. So this bridge will not initiate a Bitcoin unlocking command until all the collators have agreed to do this. And the collators, why would they do this? Why would they keep an eye on it? Because they are incentivized. So if you have an incentive layer to reward them for keeping an eye on things, for example, if every bridging charges a 0.01% fee, then this fee could be distributed to the collators who are keeping an eye on this system, and this lets them basically earn money for helping people transition Bitcoin to Ethereum. Now there's a lot of caveats here, and I should probably explain in more detail how collators work and why they would do what they're doing, but this video has been quite long so far anyway, so let's leave that for another one. I hope this quick breakdown of BTC to ETH bridging was useful to you, and it inspires you to think about other use cases that might be possible on the Polkadot network. To learn more, please subscribe to our YouTube channel or just go to the Polkadot network wiki, where we have all of this content and much more documented in great detail. Ask us about anything you're curious about in Riot or on Twitter, and we'll be there to answer any of your queries.